Hello, good morning everyone. Hello, good morning.
Morning, ma'am.
Okay.
Good morning, ma'am.
Okay. So last class we were doing the gantry girders. We have not started I think with the question, but we have I have dictated the question. I think I have shown you the question maybe. So let me share. Yeah, is my screen visible? So this was the question we had taken in the previous class. Design a gantry girder for the following datas, where we have the crane capacity is 200 kilonewton. We have the span of the gantry girder 7.5 meter. Span of the crane girder is given to you 15 meter. Self weight of the crane girder excluding the trolley. Okay, excluding the trolley, what is given here? The crane girder self weight 200 kilonewton. Self weight of the trolley is mentioned separately here, 40 kilonewton. Minimum hook approach 1.2 meter. This is point, okay, 1.2 meter. The minimum hook approach I told you, which should be kept between the trolley and the bracket or the gantry girder. Next, we have wheelbase of the crane is 3.5 meter. Self weight of the rail section is 300 kilonewton. The rail section which is above the gantry girder is 300 kilonewton. That weight of the rail section. Then we have the cell weight of the gantry girder itself is 1.6 kilonewton per meter. Weight of the rail section is okay. This thing. Okay. So take the yield stress of the steel to be 250. Now from the question we got, the wheelbase is 3.5 meter. Wheelbase is this distance between these two wheels. Okay, distance between these two, that means. So the minimum approach was given to us to be 1.2 meter. Then we have the span of the crane girder here. The span of the crane girder is how much? 15 meter it was given. So, okay. Span of the this one crane girder was 15 meter. This is 7.5 meter. It is given here. Still right. This the span of the crane girder is 7.5 meter. Oh, sorry, gantry girder is 7.5 meter. This is our crane. So the crane girder is 15 meter according to our question. This is our wheelbase 3.5. We have the minimum approach 1.2. Okay, this is the crab. Crab means nothing but your this trolley. It has its four wheels over it, and also these cranes have their wheels. Okay, so now what was our first thing? We have to calculate the maximum load. Okay, so the crane capacity was given to us in our question, which was 200 here, plus we have our trolley, obviously, because the crane will also have the weight of the trolley over it. So it is 200 plus 40, 240. The total crane capacity with the trolley is 250 kilonewton. Self weight of the crane girder is given to be 200 kilonewton. So we can find out our per meter weight. So we can find out our per meter weight, that is the UDL of the crane girder, because we know it is how much? 200 the sulfate of the crane girder is 200, and we know the span of the crane girder, this one, which is 15 meter, which is 15 meter. So per meter weight we can find out by dividing this span. So we got that UDL to be 13.33 kilonewton per meter for the crane girder, right? So now, next, once we know here what is our UDL here, the crane girder, its UDL, the per meter weight, we can calculate the reactions RARB. So if I suppose if I draw this this is our crane girder. Okay, so we have, so this one are our reactions on. Okay, these are the reactions from the support. We have here the trolley is at a minimum distance, we know the minimum hook approach. So we will have okay, this thing we know, the span of the gantry girder, sorry, the crane, this one span we know. So we will have here, okay, this is our UDL here, this is the UDL. Okay, so our UDL is, this UDL is how much? 13.33 kilo Newton per meter. Let me shift this connecting to the network. Am I audible? Why it's showing I'm not connected? Hello? Yes, visible. Okay, above. Okay, fine. Okay, so this is our UDL. Then we have this thing. What was our this load here? Because this was what? This was the total our trolley plus the crane capacity. Crane capacity is the crane plus the trolley weight. Okay, the self weight of the crane as well as the weight of the trolley. So this was how much? This was our 240 kilonewton. Okay, this, if we say this was our crane system, so we had taken this to be C, this to be D. Okay, so this reaction, suppose it is RC, we have this reaction, suppose RD, and this was how much? This span was 15 meter. Okay, suppose I give 15 meter. Okay, so now once you know this, you have this, you can calculate your reactions, right? What is your RC, what is your RD? This is D. RC plus RD. Okay, RC plus RD. So RC plus RD, we know you can calculate these reactions, right? You already know RC plus RD. These are the loads which are acting 240 plus your this UDL. 13.33 into 15. You can find out taking the moment about D. You can calculate, if you take the moment about D, you can calculate the RC value. RC into 15 minus, you have this 240 into this distance. Oh yes, one more thing, this approach was how much? This approach here, this one was 1.2 meter. 1.2 meter. So this distance also we know. So that's why it is minus 240 into this distance, 15 minus 1.2. This is 0.2, 1.2. Okay. And then we have this 13 UDL, 13 into 15 by 15 by 2 into 15 by 2. So in this way you can calculate your RC and RD values. RC we got to be this one. After calculation, we got our RC to be 320.77 kilonewton and the RD value we got to be 119.18. Okay, so now which one is our maximum? Our maximum reaction is at C. We know here is our maximum reaction. So we are going to consider this reaction. Right? So that is 320.77, the maximum reaction. So therefore now what will happen, the load on each wheel will be how much? This here you got a reaction to be 320.77. Now that means here there are two wheels, right? This was the crane because we had in this way. This is our gantry girder. Here we had the crane. Here we had the trolley. We had the trolley here. So this one we are considering now crane girder. So this trolley here, when it is moving here, we got the reaction here. Also the wheel here, the wheel of the crane girder is here on this two, above these two rails, above here, above this. So here since here we have got the reaction, maximum reaction to be 320.77 at this point here. So that means that can be divided into on the two legs. So load on each wheel will be how much? This divided by 2 we can do. So if we go, you see here, yes. Okay. So load on each wheel will be this reaction divided by 2, which is your static wheel load. The static wheel load you have to you should know what is static wheel load. The wheel load on each, the load on each wheel is nothing but your static wheel load. Because why we need to know this static wheel load term? Because here when we are adding the increase in the impact, that means I told you the different loads which are acting other than the self weights, vertical loads. So when we have, I told you about the loads. Okay. So other than the vertical loads, we had some different loads due to which, according to IS code, the impacts allowed or taken. Like suppose here now we have got the static load. We will increase this load by 25% for impact. If we see 25% of the static wheel load. This one 25 we have considered it to be the electronically operated and not manually or hand operated. So 25% we have taken impact which is allowed according to IS code. It is 25% of the maximum static wheel load. That means the vertical force, this was the vertical force, right? The wheel load which we have calculated now, that is the reaction due to which it is coming, it is the vertical load or the vertical force, you can see. So now when it is electronically operated vertical load, we have, other than when we have the reaction, we know the reaction, we know the static wheel load. So here on the vertical forces, the impact, extra impact which can be allowed, the maximum impact according to IS code, it is 25% of the maximum static wheel load. So what was our maximum static wheel load? Here if you see, that is 160.4 kilonewton, the static wheel load. So we will increase this by 25% for impact. So design load will be how much? 1.25, that means it was 1 for the 100%. So we have increased it by 25%. So 1.25 into the static wheel load, it is 25% of the added increase weight of the adding 25% with the static wheel load. So we have got to be how much? This to be design load on each wheel. So the design load will be how much on each wheel? It is 200 point. This was for single wheel load, so it is 200.50. Okay, 200.50 is our design load for each on each wheel. Now we can find out the factored load obviously. So the factored load on each wheel now is 1.5 into this wheel load with the impact after adding, after considering the impact. Okay, so that is factored load will be 1.5 into this much. Now we can also calculate this, the bending moment I talked about it. Also the shear force you can calculate here. Okay, let us calculate the bending moment first, and if it is written here. Okay, we knew what was our bending moment. Our bending moment was, how we calculate the bending moment. We will place our wheels, the wheels. This is the gantry girder here. This one. We will place the wheels of the crane girder in such a way so that it is our this distance, the CG of the gantry girder is equal at an equal distance from the CG of the wheel load and the CG of the nearest wheel. Okay, so here we have how much? If we see, see here we had the how much was our this thing, the this crane girder 7.5. So half, this is the CG, this is the center of our, okay, self weight of the gantry girder was this much, weight of the rail section was this much from the question we got, and we have taken it to be this comes out to be the self weight of the gantry girder with the rail section comes out to be 1.9 kilonewton per meter. So the factored load we know now, it is 2.85 kilonewton per meter. So we will know this is the UDL here now, right? So this is the UDL, which is this one, factored load 2.85 kilonewton per meter. Let me take this. Okay, so this was our UDL. This is the UDL, which is 2.85 kilonewton. Now the maximum bending moment will occur below the wheel loads at this point A. Suppose this is our wheel A. This is our wheel B. Okay, so we have, this is the wheel A, this is the wheel B. Our maximum bending moment is going to occur at wheel A. Why? Because our CG, we have placed our wheels in such a way so that the CG of the gantry girder is at an equal distance from the CG of the wheelbase and the CG of the, the CG of the wheelbase and the nearest wheel. So that is how much you see. This was how much? Our wheelbase was 3.5 meter, right? So this was 3.5 meter. Now if we divide this 3.5 meter, the CG, that means of the wheelbase, is this one dividing on both the sides. So 1.75, 1.75 half. Now half of this 1.75 is how much? This much, 0.875. So we got our this distance we have placed in such a way that these two distances are equal. Maybe the figure is sorry, the figure is little wrong, but here this is at an equal distance. Okay, from here to here, that you see the values. When you see the values, you will know 0.875, 0.875. So these two are at an equal distance. So now we know this thing. this values we have got this wheel, the load on each wheel, the maximum factored load on each wheel we have just calculated, which was 300.75, which has come out to be 300.75. We know these values, right? So this was the gantry girder was 7.5 meter, so half of this is 3.75, 3.75. Now um, how you will get this now? This we have found out the factored load. A and B are the two wheel loads. Maximum movement is going to occur here at A. So mm, this you can now subtract, right? You can get this distance also 70. Okay, this also you can do 3.75 minus your 0.875 will give you this distance, or else you can do this also 7.5 minus your this 3.75 minus 0.875. Okay, so in this way, this also in the similar way you can do here, which is 3.75 minus this to 1.75 minus 0.875. You will get this value. Now once you have this, once you know all these reactions from where it is coming, you can easily calculate your reaction here, this one, which is your R A reaction Ra, and this is Rb. Yes, it is mentioned here, this one Rb, this one. Okay, so let us see how much of this thing, right? Okay, we let us do ourselves here. I will just see what is the, right? Okay, so what are the reactions which we can get here now? This was Ra, Rb. Okay, fine. Now you see here, if we take the moment about A, about this moment, if we take, so moment about A, if we take, this will be Rb into this much. Let us try Rb into will be how much? Rb into 7.5. Okay, that will be equal to, now this reaction, the moment of this is equal to this loads, the downward loads. So the downward loads will be how much? This if we see 300, the wheel load 300.75 into about A we are taking, right? So about A, this will be 300.75 minus, oh sorry, 300.75 into this much, which is 2.875. Then another load which we are having is how much? This one, 300, give a bracket, 300.75 into how much? About A we are considering. No? About A, it will be 3 point, okay, we can do this thing, 7.5 minus this, 7.5 minus 1.125, this one, 7.5. If we subtract this, we'll get this direct this distance from this wheel to this point A, reaction Ra. So this will be how much? I think 7.5 to 6.375. Okay, so this will be here, we will multiply by 6.375, this one. Now the another load, the UDL is left over, so that is how much? That is your this one, how much? 2.85 into 7.5 into 7.5 by 2, right? So in this way we can now calculate our reaction Rb. Rb will be how much? Calculate this thing. Let me just tell you the answer. Rb, I see. What is Rb? After calculation, you will get your Rb to be 381.6 1, sorry, yeah, RB is 381.61 kilonewton. So in this way you can calculate your RA also. What is your RA? You can calculate RA. I think it has come out to be 1.265 kilonewton. Okay. So now once we know the reactions, we know the RA, we know the RB, we know RA and RB. We have calculated these reactions. Here, our RA is how much? Our RA is 241.265 kilonewton. RB here, this one is how much? RB is this one, 281.61, sorry, 381.61 kilonewton. So we got our reactions, these two reactions. Now once we have all this, that is the RA here, RB here, all these dimensions are, we know from where to where is the distances, we know. So here we have, this was our point A, the wheel A and the wheel B is here. So now we know our maximum bending moment is where? Our maximum bending moment is here, right, at A point, which is the maximum wheel load. So we will try to find out what is the moment here. Okay, we have calculated the reactions. We will calculate the moment now here at A. Okay, how much is the moment here? So, since we know this entire thing, what we can do is we can take the, if we take the left hand side, MA here, how many reactions will be there? Moment if we take, suppose where to write, these things will go. Suppose I'll type here, here, okay. So here, if we take left hand side, if you see, what can be our MA, the moment at point A, what it can be. These are the reactions known to us RA. RA into this distance till here at this point we are taking moment till A. So RA into this thing, RA was how much? 241.265, right, into this distance, which is 2.875. 2.875. We have another load which is here from till point A on the left hand side is how much? This one, 2.85 kilonewton, which is this 2.85 kilonewton. So plus, oh no, sorry, minus we can do since this is downward. So minus 2.85 into 2.85 sorry 2.875 how to do this, square by 2. So we can get from here the moment at A. When you calculate this, you will get your moment here, which comes out to be, let me give you an answer, 681.85 kilonewton meter. Okay. So when we are taking the moments about A, left hand side we have got it to be this much. Now let us check on the right hand side. From the right hand side, if we see, right hand side, M B, MB, if we see MB, if this moment we see taking this wheel here, because see we have taken these two wheels, right, and we can calculate the moment at A point and moment at B point. So moment at A, how much we got? Moment at A we got to be 681.85 kilonewton here, and moment at B now will be how much? Moment at B, if we do RB into this thing, same. So if we do here, RB was how much? RB was 240. Oh, sorry. RB is 381. This one here you see 381.61 into, we have this distance into 1.125 minus, we will get how much? Same thing, this load is going to come 2.85 into 2.85 into this distance is how much? 1.125 whole square by 2. So we got our moment here at MB to be 427. After calculation, you will get it to be kilonewton meter. So now you see here where you are getting the on which wheel you are getting the maximum moment. You are getting this, the moment at A. Here you see the calculations here. It is, you see here, you got your moment here on the moment at A wheel is 681.875, and at moment B is how much? 427.50 kilonewton. So you see from where, on which wheel you are getting the maximum bending moment, MA, which is at point A. So that's why we say that when you place in this way your wheel such that it is at an equal distance from the CG of the wheelbase and the CG of your not sorry, not CG, the CG of the wheelbase and the nearest wheel, you will get the maximum bending moment to be here. But if you had placed your wheelbase in this way, suppose this is your CG of the gantry girder, your this wheel B, suppose it is here. If your wheel B would be here, and your wheel A is suppose here somewhere. So the CG of the wheelbase would be somewhere here. So, and this is not going to move. This is your CG of the gantry girder. So we will place our wheel in such a way such that this distance from here and this distance is equal. So that means we are going to shift our this B to till here. If we shift now our wheel B, then this is equal, this two are equal. So now since this is the CG of the gantry girder, the the CG of the wheelbase is at an equal distance from here to, our CG of the gantry girder is at an equal distance from the CG of the wheelbase and the nearest wheel B. So now when we place our wheelbase in this way, then the maximum bending moment is going to occur here at the wheel B. Like here in this case, our nearest one was what? A point. That means our nearest wheel was A, which was at an equal distance from the CG of the wheelbase and the CG of the gantry girder. So at when we calculate, we will get always the maximum bending moment to be the nearest wheel, which is at an equal distance from uh, when the CG is at an equal distance from the wheelbase and the CG of the wheelbase and one of the wheel. Okay, so now you know whether you place your wheels in this way, whether you place your wheel B here or whether you place your wheel A here, which are nearest to the this CG of the entry girder. On that wheel, our maximum bending moment is going to occur. Okay, so in this particular question we had done this where our a this A